Hi, everybody. Welcome back to Dave's Math channel. I'm your host, David Tare, and this is my fifth bio from my Math Lovers book. I have a section on biographies of mathematicians in Volume 2, end of Volume 2, and I have bios of 80 famous mathematicians throughout history, uh, listed chronologically. I'm up to the fifth of them, and that one is Euclid, who lived from about 350 BC to about 265 BC. We don't know the exact years. As a matter of fact, very little is known about Euclid's real life. What we do know that he was a very great mathematician. I think his biggest accomplishment in math, his biggest claim to fame was his elements. He wrote the elements of Euclid, and this is kind of or for about 2,000 years, this was kind of the Bible of geometry, if you like. He started with five postulates, and these are the assumptions that went into his geometry. Five basic assumptions about lines and circles and points, and I can't remember offhand what they were, but something like two right angles make a straight line, and I don't remember offhand what they were, but I guess given 2 points, there's a single line that can pass through them. Basic things like that. The fifth one's a little bit more complicated than the other four. Actually, the original way it was worded was a lot more complicated. It got simplified in the 19th century, what became called the parallel postulate, which was still more complicated than the other four. What it basically said was if you start with any given line in the plane and any point not on that line, there's exactly one line parallel to the original line. In other words, one other line that doesn't intersect with the first line that passes through the point that's not on the line. And since that one was more complicated than the other four, for I think almost 2,000 years, there were a lot of mathematicians who tried to prove the fifth postulate in terms of the other four. They all failed. Finally, in the 19th century, there were a couple mathematicians who discovered non-Euclidean geometries. These were the geometry of a sphere. That was Riemann who came up with the geometry of a sphere. And it turns out that the first four axioms all hold for a sphere as well as they do for the plane, but the fifth one fails. There's no, lines are really great circles for a sphere, but if you take one great circle and you take a point that's not in that great circle, you get a line, another great circle that intersects the first one at 2 points, the antipodes. Um, and then there's also what's called Lobachevsky geometry, which is also hyperbolic geometry, or kind of the geometry of a saddle-shaped surface. And for that one, there's actually infinitely many parallel lines for a given line or a given geodesic in this hyperbolic geometry. If you take a point that's not on that geodesic, you actually get infinitely many other geodesics that don't intersect the first one. So the parallel postulate failed for those geometries, but those weren't discovered until the 19th century. So for about 2,000 years, this was kind of the Bible of plane geometry. And it does work. I mean, it works for a plane, for a flat surface. Euclidean geometry holds for a flat surface. And it's pretty amazing because just with these five axioms, which I didn't write down here, probably should have, you can prove everything that could possibly be known about plane geometry. You can prove all these theorems. You can prove theorems about triangles, you can prove things like the fact that the angles of any triangle add to 180 degrees. Of course, that's only true for a plane. For a sphere, it's less than 180 degrees. For a hyperbolic geometry, no, for a sphere, it's greater. For a hyperbolic geometry, it's less. But you can prove all these really nice results about arbitrary figures in plane geometry. And students of Euclid were doing this for thousands of years. So it was a really amazing accomplishment. And that this wasn't the only accomplishment by Euclid. The other things he did, I think I already mentioned in a couple other videos. Some of the other things he did, he proved there were infinitely many primes. He came up with a very clever argument by contradiction that there are infinitely many prime numbers. That's not an obvious fact at all, but he proved this around 300 BC. He also proved some results in solid geometry, three-dimensional geometry. Even though they're not part of plane geometry, he still proved them. So, very remarkable mathematician, and that's why he's on my list. And that completes my profile on Euclid, my bio of Euclid. So thank you for watching. Long live math, and I'll see you guys next time.